Okay, chemistry, I'm back with lesson 5, net ionic equations. This one is a little more complicated, but shorter. So we are making an aqueous solution. Okay, what's going on is the ionic compound is being dissolved, and you're going to end up with things that are dissolved in the water, and you're going to end up with something that is insoluble, a precipitate. It won't ever dissolve. So we have to decide what that is. So I'm attaching a reference sheet called Solubility of Ions in Aqueous Solutions. And there's a section that says ions that form soluble compounds and ions that form insoluble compounds, and you're going to be happy to see there's lots of exceptions. So it's going to be a little complicated to figure out what is being left in the water when everything dissolves. So you need to have that reference sheet. If you can print it at home so you have a hard copy of it, that's great. You can jot it down if you want a hard copy. There's not that much, or just have it on your computer somewhere where you can reference it. Because in the end of these equations, you're going to have to look at it to see what can be soluble and what isn't. So when things are going to dissolve in water, and then, or maybe not in water, in something, and then there's going to be these spectator ions that are not part of the reaction, and they're just there to watch, like spectators are in a sport. They're not actually playing the sport, they're just watching the sport. So those spectator ions, in the end, we're just going to get rid of because we don't need them. Okay, so we're going to, when we do these problems, we are going to write the formula, write the complete ionic equation, and then we're going to write the net ionic equation. So let's look at an example. You can go through the notes to see what happens and to see pictures of what happens to the ions. But let's look at some examples. Let's start with, on the back page of your notes where it says practice. I think it will make more sense if I just do some of them. Okay, where it says practice, it says write the formula equation, complete the ionic equation and net ionic equation for the reaction when two solutions, aluminum nitrate and ammonium sulfide, are mixed. So that's what we got to start with. We got to start with aluminum nitrate. So we got to make that. We got aluminum and we got nitrate. Nitrate is NO3 with a -1 charge, and aluminum has a +3 charge. So that is going to become AlNO3, and that's aqueous solution. Okay, and then our second one is ammonium sulfide. And ammonium is NH4 with a +1, and sulfur has a -2. So that becomes NH4 2S. So I made that part of my A too long. And that is going to make something that is going to make, we're going to do a double switch replacement. So we're going to take, we got to put the positives with the negatives and so on. So we're going to take AL and put it with S. We're going to take this and put it with that. And we're going to take this and put it with that. So we got AL and S. And aluminum has a +3 and sulfur has -2. So that becomes Al2S3. Whoops, I put that in the wrong spot. And ammonium has a +1 and nitrate has a -1. So that just all goes together of NH4NO3. Okay, now we have to decide on this side of the equation over here, which one of these is still an aqueous solution and which one is the one that is a solid. We have to decide. So this is where that reference sheet is going to come in. You're going to look on your reference sheet and it has ions that form soluble compounds and ions that form insoluble compounds. And if you look on here, sulfur is insoluble except when it forms with group 1 ions ammonium. And the NO3 okay, so sulfur is insoluble, so that means it can't dissolve. So this is going to be our solid, and this is going to be our aqueous solution of this side of the equation. So we've written it here now. Now we have to balance the equation. We got 2 aluminums, 1 aluminum. Let's put a 2 here. That gives us 6 nitrates. Over here we have 3 nitrates, so we would have to put a 2. That gives us 2 ammoniums. We got 2 ammoniums, but we've got 3 sulfurs, so we're going to have to put a 3 here. And so we're going to have to do something else because it's not balanced. We got, over here now we've got 6, so we're going to have to make this a 6. So now we got 2 aluminums, we got 6 nitrates, we got 6 nitrates, we got 6 ammoniums, and we got 3 sulfurs. So everything is balanced right here. This is balanced. So when it says, write the formula equation, this right here is the formula equation. I'm going to write it a little bit neater. Okay, that's an aqueous solution. This is an aqueous solution. This is a solid. And this is aqueous. Okay, this one over here, this is the solid. And we figured that out from looking at that reference sheet that I just attached for you. This is the formula. This is the formula equation. Next part, the complete ionic equation. Okay, so for the complete ionic equation, we're going to take the formula equation and we're going to break all the things apart. This is going to get longer than the one we just did, so I might have to make two lines. And when we do this, we're going to put the charges above the elements. Okay, we got 2 aluminums, so we're going to write 2Al and with a charge of +3, and that's aqueous. Plus we have 6 nitrates, which has a -1 charge. A lot of times we don't put the actual 1 if it is a 1. We can just put negative. That means -1. That's also aqueous, so we divided that up. Plus we have 6 ammoniums, and that had a +1 charge. That also was aqueous. Plus we have 3 sulfurs, which had a -2 charge, and that was aqueous. And that yielded the solid. We're going to keep together because the solid doesn't divide out in the solution. And then the last one, 6NH4 with a +1 charge, and 6NO3 with a -1 charge. And now we can get rid of the spectator ions that don't mean anything for this equation, that are the same on both sides of the arrow, because they don't do anything. They don't bring anything. They're here, like this 6 nitrates right here is also just sitting over here. It doesn't do anything. There's 1 here, there's 1 here. We can just cross them off. Okay, it's a little bit like in math. When you have the same thing on both sides of the equal sign, they just cancel each other out. This, we got these 6 and we got these 6. They don't bring anything to the table. We can just cross them off. Okay, before I did all this crossing, that was the complete ionic equation. So now in my complete ionic equation, I'm going to cross off my spectator ions, and I'm going to be able to write my net ionic equation of what's left. I got 2Al plus 3S, and that's going to give me Al2S3, and that is my net ionic equation right there. Okay, so they asked for 3 things. They asked for the formula equation, which was on the page before. They asked for the complete ionic equation, which was this right here. And then the net ionic equation when we get rid of the spectator ions. So let's try another one so you can have practice with this. Let's use another color. Okay, 2 solutions: calcium chloride and sodium carbonate. So we got to start with calcium and chloride. Calcium has a +2, chloride has a -1, so that becomes CaCl2. And sodium carbonate, which is carbonate is CO3, and that has a -2, and sodium has a +1, so that becomes Na2CO3. And then we're switching. Now our calcium is going to have to go with our carbonate. So we're going to take calcium and carbonate. Calcium has a +2, carbonate has a -2. So that's just going to be calcium carbonate. Oh, I'm not going to write that yet because we haven't decided for that. Which one is the solid? And then we're going to put sodium chloride, and we know that that is NaCl because we've done that a lot, but it has a minus, +1, -1. So that's just NaCl. So we're going to look on our reference sheet that I gave you, the solubility of ions, and see which one is insoluble. Okay, is carbonate, it says right here, carbonate is insoluble when except there's an exception, but we're not using that exception. And if you look up at the top, Cl, chlorine is soluble. And so this is going to be the aqueous, and this is going to be the solid in our product right there. So now we've got to balance. We got Ca and Ca. We got 2 Cl. Oh, we only have 1 Cl over here, so we're going to have to put a 2 there. That gives us 2 sodiums. We've got 2 sodiums, 1 CO3, 1 CO3. I think that takes care of everything just by putting that 1, 2 right there. So this right here is the formula equation. Okay, that's the formula equation. The next thing is the complete ionic equation. Okay, that's where we're going to divide these all down with their charges. So we got Ca, which has a +2, and they always write them with the plus and minus on the other side. I'm not sure why. Plus 2, and you always put the number of how many there are out in front. We've got 2 chlorines, which has -1, so we can just put a minus, plus 2 sodiums, which has a plus charge of 1, and 1 CO3, which has a -2 charge. We're keeping the solid together. Whoops, I did that wrong. Yields, we're keeping the solid together. And we got 2 sodiums, which has a +1, and 2 chlorines, which has a -1. Oh no, I lost it. Here it is. 2 chlorines, which has a -1. This is the complete ionic equation right here. Now we're going to start getting rid of the spectator ions, the things that don't bring anything to the table, that are just sitting around watching. Okay, we don't need these, and we don't need these. So for the net ionic equation, we have Ca plus CO3 yields CaCO3 as a solid. And that is the net ionic equation right there. So this is what the formula equation looks like. This is what the complete ionic equation looks like. And then this is what the net equation looks like. Okay, let's do the last one that is on your notes. We've got sodium, phosphate, and aluminum sulfate. Okay, sodium and phosphate. Phosphate is PO4, with a -3 charge, and sodium has a +1. So that becomes Na3PO4. And over here we have aluminum sulfate, and that has a -2, and aluminum has a +3, so that becomes that. Now we're going to switch, and sodium is going to go with sulfate. Sodium is +1, sulfate is -2, so that becomes Na2SO4. And I'm not going to say what that is yet because we got to look on our sheet. And aluminum phosphate. Aluminum is +3, phosphate is -3, so that's just aluminum phosphate, like that. Now we got to decide which one of these is the aqueous solution and which one is the solid. You're going to look at your sheet, and you're going to see that SO4, which is sulfate, is soluble, except when it's in a solution with some things, which is not sodium. So that one is soluble. So we're going to look at this one. Phosphate, PO4, is not soluble. So that means this is going to be the solid, and this is going to be the aqueous solution. Right there. This is the formula equation. Now let's do the complete ionic equation. Okay, with charges. There are 3 sodium here. So we're going to say 3Na with a plus charge. There's 1 phosphate, PO4, with a -3 charge. There are 2 aluminums with a +3 charge. And there are 3 sulfates with a -2 charge. And those yield 2, I forgot something. We have to, I got to erase that, I'm sorry. We have to, we got to balance this equation, the formula equation up here. It's not balanced. So let's go ahead and balance it. We got 2 aluminums, so we got to put a 2 here, and that gives us 2 phosphates, so we're going to have to put a 2 here. That gives us 6 sodiums, so we'll have to put a 3 here. That gives us 3 there. Now I think everything is balanced. Now we can do the complete ionic. See, I'm learning this too. So now we don't have 3 sodiums, we have 6 sodiums with a plus charge. And we have 2 phosphates with a -3 charge. And we have 2 aluminums with a +3 charge. And we have 3 sulfates with a -2 charge. And that yields 6 sodiums with a plus charge and 3 sulfates with a -2 charge, plus we keep the solid all together. This is the complete ionic equation right there. Now to find the net ionic equation, we're going to start crossing things off in our complete ionic equation, things we don't need. The spectator ions that are just hanging around that we don't need. So those can cross off, and we can write our net ionic equation as 2 PO4 plus 2AL yields 2AlPO4 solid. And that is your net ionic equation. Okay, so you don't have very much homework for this assignment. You only have 2 that you need to do. So you need to try to do those 2 problems that are on your homework. And if you have questions with any of these things, please contact me. I don't want you to spend hours and hours and hours trying to figure it out by yourself. Go ahead and contact me if you're stuck somewhere, and maybe I can give you a hint to get you going. So this is the last video for this, these things that I sent home with you last Friday. So you need to get your homework turned in. Check Google Classroom to see when your different homeworks are due. And if you have questions, please don't hesitate to ask.